Okay, welcome to this opening video of the Advanced Programming course, where I'll be showing you how to get started with exercises. So I'll already opened the course website. I hope you know how to find it. The course website is a work in progress, but the link to the code is already there. So all our code is going to be shared by this GitHub itu.tk repository. Note that this is an internal ITU GitHub setup. It's not github.com. So you need an account on that, and if you're a new student, that may take some time to set up, so you've been warned. Now what we need to do is to clone this repository, so let me grab the link and let me open the repo. Maybe I'll clear this. Git clone repo, and it's going. And now I landed a directory called 2020 ADPRO, which contains, maybe this is the better way to see it, the following files as of today, and it's going to change all the time during the course, so I recommend you pull from this repo regularly. So what do we have here? We have some top-level files, the still not updated Docker file that I will soon update for this edition of the course, a quick README explaining what's in here. But the most important thing is 010 intro, which is the directory for the first week, containing all the files you need to succeed in the first week of the course. On top we have the build script, then we have the PDF files with the exercises and with the slides for the lecture. Then there is a project property file. You normally don't care about that. It's a local setup thing that I take care of. As for README file explaining what's in here. And then the source directory. In the source directory we have two sections. We have the main section and the test section. In the main section is usually where you work. These are the files that that are either examples from the lecture or are exercises to be solved. Normally we explore these files by reading the PDF file, and it tells us which file to open and how to read. Then the test files are written there to help you to check whether you have solved the exercises correctly, at least up to functional correctness. Okay, so we should almost start to work on these exercises now, so I'll go there. So now I'm inside this directory. Whoa, what has happened? Yeah, everything is alright. Yeah. Before I do that, I note that I have Java installed, and as of today, this seems to be this version of Java 11 on my somewhat old Ubuntu that will be upgraded in a day or two. But it does work on the old Ubuntu. Then I also need an SBT version, SBT installed, and I have something installed here. Let's see what it says. SBT is a bit slow to boot. Or maybe this is also the wrong command I gave it. It succeeded. It's version 1.13. And actually SBT printed two informations. Here is the information which SBT is installed in this project and which SBT is installed in the system. This happens to be the same SBT on my computer, but it doesn't have to. It suffices that you have SBT above version 1.0 installed on your computer. Then it will pick up the right version for running the build script. Another thing that I can show you is to show that how SBT can be used to interact with Scala. So SBT console. And this thing is a bit slower the first time you run it. Since I use Scala fairly regularly, mostly to prepare your course, then for me it runs faster than it will for you the first time, because it has to download the Scala compiler and all things necessary. So what I have here is it opened at a console of SBT, that a console of Scala interpreter, the so-called REPL, read, evaluate, print loop, that is already configured for this project. Importantly, it's the right version of Scala that we are using in this project, in the entire course, 2.13.3, and it's also it also contains all the classes on the class path. I can show that you need to work with. It should actually work. So for example, in these exercises, I think there is something called my module, and I can import from it. So the files have been compiled and the class files are available in the class path, so I can work with the current project. I can rip it open and experiment with parts of it. That's very useful. I can also run expressions, and etc. Yeah. I'll exit now. I'll note that I also have Scala installed on my PC, but this is almost irrelevant because I almost never use it. So that's not the same Scala we've been running out above. On my PC, the default Scala is 2.11.12, which is an older version and incompatible with the current exercises, and it's not a big problem for me because SBT is downloading and running the right version of Scala for me. So you don't have to have Scala installed at all on your computer. SBT will take care of it, except if you would like to do some experiments outside the project scope, then the exercise project scope, then it's occasionally useful. I use it very rarely, but I still have it. Okay, so normally we actually don't run SBT from command line all the time because that's too slow. We just open SBT's command line, which makes things much faster. Now I can, for example, say console, and it's much faster to open the console than it was before. Or I can leave it. I don't remember how I leave it actually. Jesus, how do I leave it? Maybe just go. Now maybe quit. Yep, it has worked. Now I'm back and I can issue another SBT command test. That's actually a command that you have to familiarize with yourself. So now it's a bit slower because it also needs to compile test classes that it didn't before, and it has sent back a long list of failing tests. So there is 24 tests that have failed, and once you have finished the exercises, the tests will be passing. That's how you know. Okay. So let's start working on these exercises. I don't normally work in a terminal like that. It's a little inefficient. I like to do something else. So let me first open the exercise. No, it's not called main. It's called intro exercises PDF. Let me open the exercise PDF file. So these are the things we are working on. Maybe I'll make it a little smaller. So it explains all the stuff I just said about SBT, but in writing. It says that there is no mandatory handling this week and we want to work on exercise 1. We already have our repository cloned, but we are being asked to work with a file called my module Scala. So let's go in there. Me and typing. So let me maybe start with opening the build script. And just to spare your eyes, I will reduce the contrast. Nope, that's not what I wanted. This is what I wanted. Okay, so this shows the build script. You normally you never really need to modify it, but I like to open it. It's my habit to have it open, so I did. And from here I'm going to open this file called my module Scala. That's the file you might recognize from the exercise. I'll also split screen here, and here in the bottom I will open a terminal. I will open SBT. And I will start the test command in a loop that's signified by this lambda tilde that will be running the files whenever I change, when we're running the tests whenever I change the input file. So now all the tests are failing. Actually, if we go up here, we can find the tests for my module. Which is, yep, it seems that there is 2 test cases for the first exercise, my module spec, and they're both failing. One says that it should not throw exceptions, and it does throw an exception, and it should behave like a square, but it throws an exception instead. Okay, so what are we asked to do? We read this file. To compile all files in this weak directory, well, we know how to compile now and how to test. I didn't try to run it. Maybe I should try to run it to show you. This file has a main function, and that's we can run it. So maybe I actually do it. I do the run command, and now I have a choice between dynamic dispatch main and my module. That's the my module that we are looking at. So I'm going to say 3 and enter, and it has run. The absolute value of -58 is 58, which is what this function has produced. Just if you ever wondered how to run the main function. But I'm going back to the test. As the exercise tells me, now run the test command, and you see a lot of things are failing. So we are being asked to complete the implementation of the square function in the my module Scala, and we're going to replace the placeholder 3 question marks. So 3 question marks is actually a Scala function, and this is a call. That function, the only thing it does, it throws a non-implemented exception. So that's exactly why when we look at the tests for this exercise, here, right, we see that we are receiving a Scala.not-implemented error exception. So you'll get used to this. In this course, I will give you a lot of files with 3 question marks at some location, and your task will be to replace the 3 question marks with a piece of code that provides the functionality expected. And so that's the exception you'll be seeing a lot. When you have implemented everything, that exception will disappear. It's very useful to use an exception here, because the moment I put an exception as a whole, as a placeholder for your code, the code is possible to compile, and you can still use the functions that are implemented and test them and experiment them with, etc. So you don't have to solve all the exercises before you can run them. You can do them one by one, and actually you're recommended to do them one by one and in the order of the PDF file, unless it says otherwise. Okay, so we have to write a square function. That's not a very complicated thing. So, well, how could I implement square? That's not very hard, right? Let's say that square is n times n. And I save the file. That has been now saved. In the meantime, it's just we are not scrolling. These tests have been rerun. Only 22 tests are now failing, which suggests that 2 tests are passing. 2 tests are now passing. I can quickly find that spec about, and you can see here that the my module spec for square is now, it should not throw exceptions, and it passes, and it should behave like n times n. Well, it does. This way we have solved the first exercise. So the second exercise is to try to experiment with this in the REPL. So I stop this build process, pressing enter, and I start the console, which drops me into this module, and I can call the functions from my module now by qualifying them. So my module is, well, it needs parameters. If I put an underscore, I can give me the function value corresponding to this method. That's a function from integers to integers. But I can also execute the function, so a square value of 1 is 1, a square value of 2 is 2, square value of 3 is 3, etc., etc. You know the drill. So that's the REPL, and it's often quite useful to understand better what's going on once things compile but still don't pass the functional tests. Most feedback in this course you're going to get from the type checker. So actually the compilation errors are much more important to interpret, but REPL is also useful at once in a while when things seem to compile but still not do what we expect them to do. Also, REPL sometimes can be useful to prototype an implementation so that you know that it type checks. Let's say I want to prototype the body of my function square. Maybe I write it as a lambda expression. Okay, that seems to type check. Then I could possibly take this body and copy it to clipboard and paste it here. Well, it's the same body, so nothing has changed, right? But I could have developed in the REPL and moved it here. That's how many people like to work, and I sometimes do if the types get very complicated. Since I'm fairly experienced with this now, I often see how things should be done, so I rumble right away in the Scala file. But if things get a little bit complicated and you don't know what to work with, it might help to experiment in REPL. Also, REPL, at least depending on your setup, actually, I'm not entirely sure it will work. It doesn't seem to work here. I don't know what's misconfigured on this computer, but quite often in the Scala REPL you also get tab completion, so you can see what methods are available, and that is quite useful. What else is in the exercise? I'm checking. So we have called my module and square interactively, and well, we didn't store the results. Well, we did, because Scala immediately stores the results in a temporary variable with a new name. So the result of the last call is still in res4 and it's 9. But if I wanted to name it, then I would say my result, my module. Oh, what did I do? Well, my result, my module square. Let's say 42. Yeah. And now my result stores the square of 42. This variable remains in scope as long as nothing else hides it, and as long as we don't exit the Scala interpreter. So we can then, for example, compute square of my result. Okie doke. What else is here in the exercise? Well, you noted that since the variables are in the module or object my module, I always qualify the calls to square, but I can also import my module. I can import all the functions from my module, then I can call square directly. Right, that's the same square, and the import has a similar meaning to Java. This is like a Java static import. Okay, so the next thing to do is actually to, let me exit the terminal, the exercise 3 is asking us for the file exercises Scala, so here they are. And this is the exercise 3, and as you can see there is lots of hole here, one in every exercise, and the first is asking you to implement the Fibonacci function. So what you're going to do is you're going to replace this with the implementation. Read the text of the exercise carefully. Then we're going to run the tests, and the number of tests failing will be decreasing. So the tests in the exercises are inversely sorted for your convenience. So actually the Fibonacci tests come last, right? So all these tests failing here are for exercise 3. Once they all pass, they will turn green, and then you go up and see what are the tests for exercise 4, etc. With this, I think I would like to wish you good luck. Of course, we will be working on these exercises during the exercise classes with TAs and myself to help you, and also there'll be other ways to get help on the online forums, etc. But I hope this video already gets you started well. Good luck.